Hi, I'm Fumitaka Sato from Kindai University. In this presentation, I'd like to demonstrate interactions between the gut microbiota and IgA expressions in the thyroid virus-induced multiple sclerosis model. I have no conflicts of interest. Multiple sclerosis (MS) is an inflammatory demyelinating disease in the central nervous system. The exact pathomechanism remains unclear, but multiple sclerosis has been considered to be triggered by autoimmunity and/or viral infections. This theory is supported by clinical studies. For example, myelin-specific T cells and anti-myelin antibodies have been found in some MS patients. Viruses such as Epstein-Barr virus, human herpesvirus 6, and picornaviruses have been detected in some MS patients. This theory is also supported by animal models. In this study, we use thyroid virus. It is a non-enveloped, positive-sense, single-stranded RNA virus that belongs to the picornavirus family. Intracellular injection of thyroid virus into SJLJ mice causes motor disability during the chronic phase 1 month after viral infection, like this. In this phase, we can see inflammatory demyelination and persistent viral infection in the central nervous system. Since this resembles multiple sclerosis histologically, thyroid virus is used as a viral model of multiple sclerosis. Here, several immune effectors have been proposed to cause inflammatory demyelination, but we still don't know how immune system could be activated in multiple sclerosis or thyroid virus model. One of the candidates is the gut microbiota, since the gut microbiota has been shown to activate immune system contributing to viral clearance. But overactivation of immune system by the gut microbiota has been suggested to damage not only the gastrointestinal tract, but also remote organs, including the central nervous system. In addition, the microbiomes in multiple sclerosis patients were different from the healthy controls. So, we hypothesized that changes in the gut microbiota overactivate immune system, leading to inflammatory demyelination. To address our hypothesis, we injected thyroid virus intracellularly into SJLJ mice and conducted a time course study by harvesting spinal cord and feces 1 week and 1 month after viral infection. Using RNA sequencing and 16S ribosome RNA sequencing, we examined the spinal cord transcriptomes and fecal microbiomes. We also determined interactions between immune gene expressions in the spinal cord and gut microbiota using pattern matching. First, we determined gene expression in the spinal cord following thyroid virus infection. These heat maps show the top 20 of highly upregulated genes in the spinal cord during the chronic phase compared with the controls. Among the 20 genes, we found increased levels of intestinal immunity-related genes, IgA heavy chain and J chain, from which dimeric form of IgA is produced. As you know, IgA positive cells are present generally in the gut. but not in the spinal cord. Since this result was intriguing, we confirmed IgA positive cells by immunohistochemistry. As you can see, IgA positive cells were seen in inflammatory demyelinating lesions. This slide shows the results of gut microbiota. We found that thyroid virus infection increased different bacteria, Marvin bryantia during the acute phase and Coprococcus during the chronic phase. Both bacteria belong to the Clostridium order. Lastly, using the spinal cord transcriptome and fecal microbiome data, we tested whether there are any correlations between IgA gene expression in the spinal cord and altered gut microbiota. Pattern matching showed that increased Marvin bryantia genus during the acute phase correlated with IgA gene expression in the spinal cord. On the other hand, during the chronic phase, the increased Coprococcus genus correlated with IgA expression in the spinal cord. In conclusions, thyroid virus altered the gut microbiota during the acute and chronic phases. During the acute phase, increased Marvin bryantia correlated with the upregulation of IgA in the spinal cord. On the other hand, during the chronic phase, we found the correlations between the Coprococcus abundance and IgA positive cells in the spinal cord. Although we still don't know whether IgA is good or bad in this model, the altered gut microbiota could activate IgA responses, contributing to thyroid virus-induced inflammatory demyelinating disease. To further address our hypothesis, we will conduct a loss of function study using IgA knockout mice. I appreciate my laboratory members. This work was supported by Kakenhi and Ahmed. Thank you for your attention.